Welcome everybody to the Weddell Sea Expedition video conference for today. Today we have two very special guests coming to us from England. They have just come off of the ship down in Antarctica. So welcome to our video conference. My name is Lizzie Rosenberger and I am with Reach the World. And this video conference to you today is brought to you by Reach the World and the Explorers Club with support from the Flotilla Foundation. So today I am thrilled to introduce you to Professor Julian Dowdeswell and Evelyn Dowdeswell. And Julian is the chief scientist for the Weddell Sea Expedition. And he is the director of the Scott Polar Research Institute and also a professor of physical geography. He loves glaciers. They both love glaciers and geography. And today they're going to talk to us a little bit about the science that has been happening down in the Weddell Sea. They have been there conducting science since the beginning of January and have lots to share with us. Evelyn is also a glacial geologist and a research associate at the Scott Polar Institute with the University of Cambridge. They both have worked in the Arctic and the Antarctic. So on both sides, both polar sides of the globe. So they have lots of background and information about the polar regions. Evelyn has also written 2 children's books about Antarctic explorers, one that we have heard lots about, Ernest Shackleton, and another one, Captain Robert Scott. So I'm going to unmute Julian and Evelyn for them to say hello to you, and then we will come to each class for each of you to say hello to Julian and Evelyn.
Hello everyone. Hello everyone.
Hello, nice to see you today. Oh, we can see you waving.
Yes, so now we are going to go ahead and I'm going to introduce each of you of the classes, and when it is your turn to unmute, I will unmute you and you can say hello. So Miss Patterson or Connie Patterson, you are all ready unmuted, so you can go ahead and say hello. And Connie is calling in from Canada, correct? I think we froze a little bit with Connie. Excellent. Next we...
Hello.
There you are. Perfect. Next we'll go over to Mr. Lee's class from California. You can say hello.
Hi. Hola. What's up?
Excellent. Next, we have Miss Bemis's class, and you all are calling in from Connecticut. And Miss Bemis, you're going to have to unmute them to say hello. All right, give us a big wave, Miss Bemis's class. There we go. Excellent. Next, we have Michael calling in from Massachusetts on behalf of his whole class that he's going to report back on the call today.
Hello.
Hello, Massachusetts.
Hello, Michael.
Wonderful. Next, we have Lucy calling in from British Columbia.
Hi.
Hello, Lucy.
Hi, Lucy.
Hello, nice to see you.
And next we have Miss Long's class, who is calling in from Colorado.
Hello, Miss Long's class. Hello, everyone.
And then we have Miss Hoggerturk's class calling in also from British Columbia.
Hi.
Hello, British Columbia. Hello.
And we have Miss Suzuki's class. We don't see a video of them yet, but they are calling in from Illinois. We can hear you if you say a big hello.
Hello. The boys and girls will be back in about 15 minutes. We can't wait to join you.
Perfect.
Thank you.
And then we also have Mr. Rowett's class, who are calling in from New York.
Hey everyone. I'm going to greet everyone with this.
Oh, very
Hello.
cool. Hello.
Yes, all right.
And we have Miss Kokoris calling in from Connecticut. Could say hello. All right, and then we also have Julie Chase, who is joining us from the Explorers Club as our the VP of Research and Education for the Explorers Club.
Hi, Julie.
Hi, Julie.
And lastly, we have my colleague Colin, who is going to be working with our chat. So for all teachers and students out there, if you have questions or comments during the video conference, you can feel free to put them into the chat feature, and Colin will be checking on that and telling us what's happening there. So without further ado, I am going to turn it over to Julian and Evelyn to tell us a little bit about the Weddell Sea and what they have been up to down there and their work.
Thank you. Well, it's really nice to be here and talk to everybody. We just the other day got back to England after over a month on the ship in the Weddell Sea, and we did all sorts of scientific things there. And of course, there's also lots of things to see when you're on a ship like that too. And I think we've got 1 or 2 slides to introduce this. If you could put them up, that would be great. And then we can show you a little bit about what we do with the slides, and then take it from there with questions and so on. Right, good. So we can see the slides. So the first one just shows, firstly, the logo of the expedition. And the reason we have a logo, which is a seal breaking through the water and the sea ice, which is the frozen sea surface, is because the Weddell Sea is almost completely full of sea ice for most of the year. And the ship, which is an icebreaker, has to break through that sea ice. And also, the particular kind of seal in the picture is what is named a Weddell seal after James Weddell, who discovered the Weddell Sea in the 19th century. So that's where the logo came from. And then what you see next to it on the right is a picture of where we landed when we first came into Antarctica, because it's a long way from Britain to Antarctica, and we had to fly all the way from Britain, first of all to South Africa, and then on a very small chartered jet into the area that you see on the right here. And this is me driving a snowmobile around with some of our kit. And we also stayed for a few hours in one of these little camp tents just here. And look at the beautiful mountains in the background. That mountain is called Wolf's Fang, and it's right in the area, in the interior of Antarctica. And believe it or not, the ice that we're on here, the ice is about 6,000 feet thick underneath us, because we're there in the interior of the Antarctic ice sheet. And from there we got another little aeroplane to the coast where we got onto the ship. And the other picture here, it's already been mentioned that Evelyn has written a couple of children's books on Antarctica, and I and a friend of mine wrote another book, and you can just see the cover of it here. It's called The Continent of Antarctica. It's actually about the oceans around Antarctica too, but it's called The Continent of Antarctica. So can we have the next slide, please? Here we are. So this is about the expedition. And here you can see, first of all, the wing of the aircraft where we flew into the coast of Antarctica. And you can see the ship that we worked on. This is the ship called the Agulhas 2. It's named after the Agulhas Current, which runs around part of the Southern Ocean. You can see the ice cliff here, and those little dots of people and a little camp on the ice there too. But we're looking down now at the ship, which is about, let's see, we usually work in meters in Britain, but let's convert it, 140, 280. The ship is about 400 feet long or something like that. At the back, the green bit at the back is a helideck, and at the front you can see a crane. And then on the right of the image, you can actually see the ship at the edge of a big ice floe. This is part of the frozen sea surface in the Weddell Sea. And in the foreground, you can see there are 2 drones, and those drones are going to help us they helped us on the expedition to measure the shape of the surface of the ice floes. And then the third picture on this page is the jet that we came into Antarctica on, just taking off after we'd come off that 5.5-hour journey from Cape Town to the interior of the Antarctic ice sheet. So the aim of the expedition is very simply to understand the way that Antarctica, the continent of Antarctica and the oceans that surround it influence the global environmental system. Because one of the important things to remember about Antarctica is it's not just what happens in the continent that affects the continent itself. What happens in Antarctica, and the same is true of the Arctic, what happens in Antarctica influences the whole of the global climate system. So for example, if ice melts in Antarctica, the water that's melted from the ice sheet goes back into the global ocean, and that acts to raise sea level everywhere in the world. So that's one reason why Antarctica is important globally and everybody who lives near the coast. The second one is, as that ice melts and also as the sea freezes, salts are produced, and that produces very, very dense, cold and salty water, and that water flows northward from Antarctica in the deepest parts of the ocean, and some of it even ends up in the North Atlantic or places like New York. And that cold water flows northward at depth, and the return flow near the surface is also part of the global circulation of the ocean. So what happens in Antarctica and the amount of sea ice formation, the amount of dense water that forms, affects the whole of the global climate system and actually the way that the global ocean circulates. So let's see, and then so if we look at the so if we look at the third slide now, we can see some of the things in action. And here's Evelyn. This is actually a picture of Evelyn. Do you want to say what you're doing, Evelyn, in the third picture?
In this picture here, I'm measuring the thickness of the snow that sits on top of the sea ice. And it's really important for us to understand how much snow is on the sea ice and how much ice is below it, because we like to measure the thickness of these sea ice flows from satellite images. But in order to understand what we're really looking at, we need to know how much is snow and how much is ice. So it's very important. So I'm measuring, I'm holding it looks like a stick, it's a snow probe, and I push that down until I get to the ice layer, and it has a GPS system on top, so it tells me exactly where I am and how thick the snow layer is above the ice.
So in the picture, you can also see the autonomous underwater vehicle or underwater robots that we actually used in order to investigate the seafloor, the under ice, the undersea shape of the floating sea ice, and also how salty and the temperature of the water. And then the big square yellow vehicle in the middle picture is called a remotely operated vehicle, and that can go right down to the seafloor and take super high resolution photographs of the seafloor. And then we can see the rocks on the seafloor, and we can see individual plants and animals on and around the seafloor in Antarctica. And because the Antarctic has hardly been looked at before, the deep sea around Antarctica has hardly been looked at before at all using such instruments, almost always we find completely new things in the biology of the Antarctic waters. So you can see from the slide that we have several science teams on the expedition. We're studying glaciers and ice sheets and the icebergs that are produced from them and float off into the sea. We're looking, as Evelyn said, at the sea ice, which is simply the frozen sea surface and is only a few meters in thickness. And then we're looking at the marine biology and also the oceanography, the temperature and saltiness of the ocean and the way that the currents work to transfer that salt to more northern parts of the world. And importantly, our group of scientists is from a number of countries around the world. In fact, the cruise leader actually counted up the number of different passports that we had on the expedition, and it turned out people had 20 different nationalities of passports, although some people had passports from more than one country, so it's not quite 20 in total, but more or less. And you see people came from the UK, that's the United Kingdom of Great Britain and Northern Ireland. We're from England within the UK, from South Africa, from New Zealand, from the Netherlands or Holland, from Norway, from Russia, from the USA, and from France. And I should say, because Evelyn probably won't say it, that although she's been married to me for 35 years and our children are in England, Evelyn is actually originally from Southern California, and we met, and this is topical in terms of the schools watching, we met when we were both doing master's degrees in glacial geology in the University of Colorado, in Boulder, Colorado. I know no one of the schools is from Colorado, so I thought I'd say that too. So that's just a very, very brief introduction to the expedition, and just to point out again how important the Arctic and the Antarctic in particular are as things that drive the global climate system in terms of global sea level rise, which is affected from Antarctica, and also the circulation of water around the global oceans, which transfers heat all around the globe from the equator to the colder regions. So that, if you like, is the general context. And now we're very happy to answer some questions, if you like.
I'll just say,
yes, please.
Sorry, while we're looking at that picture, can we go back to that picture for a moment? Oh, thank you. The main difference, in the bottom, you can see an orange submarine-like vehicle, and that's going to be used, that is used to explore the sea floor. But the main difference between that and the yellow box like ROV, remotely operated vehicle in the middle, is that the orange torpedo or submarine like shaped instrument is completely independent. There's not a cable or anything attached to it. It can go under its own power, whereas the big ROV in the middle, the yellow box, that will be cabled. That will be used with a cable the whole time. It goes under the ocean, under the seafloor.
Great. So we'll go to some questions, if you like, then. Thanks, Evelyn.
Sure.
Yes, wonderful. So we are going to open it up to our students to see if you have any questions. And with our students, as always, when you have questions, just make sure you put your hands up nice and tall so that we can see you in the screen. And you can ask about any of the science that they did, anything about glaciers, sea ice, marine biology, and oceanography as well. So it looks like Miss BMS's class has a question first, so we'll start there with Miss BMS's class. So let me unmute you. And you're going to have to help me unmute you as well. And we are ready when you are. Go ahead.
Me? How big was that probe stick that she was holding going into the snow or ice?
I'm afraid we didn't quite hear that. Could you speak a little bit louder? Perhaps. Is that all right?
How long was that probe stick that was in the ice?
How long was the probe in the ice, Evelyn?
Oh, do you mean the orange submarine-like thing?
No.
The stick.
Your stick.
Oh, my
Evelyn.
stick.
Your
Oh,
stick.
that's a really good question. It's about just a little bit more than 3 feet long. And one thing that's really interesting, in this part of Antarctica, the snow on top of the sea ice is a lot thicker than we expected. So there were some times when I pushed the pole all the way down and I never got to the ice, the boundary between the ice and the snow. So I had to dig a hole and then start again because it was over 1.20 meters. About 3 feet, 4 feet thick. So that was what I did. I walked, and then every 3 feet I'd take another measurement so I could get a whole profile of the snow thickness.
So one of the points that Evelyn's making more generally is that one of the things that's really great about science is that you don't always find what you expect, and that's what makes it exciting. So we thought that there might be a couple of feet of snow in this place, and what Evelyn discovered through using the probe that you were asking about is there's probably 3, 4, 5 feet, which means that it's much snowier in that part of Antarctica than we previously thought. And of course we didn't really know at all before, because almost nobody's ever been to this part of Antarctica before.
Wow. And how long did it take you when you had to go every 3 feet to collect another piece of data? Was that 1 day, 2 days? Was it a couple of hours?
Well, each time we went on the sea ice, we had a 3 hours time limit because it's very cold. We were dressed warmly, but there are also other scientists who wanted to work on the sea ice. So it took us about 3 hours to do our part of the research, and then another team came out for another 3 hours.
Excellent. And that seems like that's pretty important to think about the climate and the teamwork when working somewhere like Antarctica. Mr. Lee's class, Looks like they have a question as well. So we'll head over to Mr. Lee's class and then we'll go down to Miss Long's class. So Mr. Lee's class, you are unmuted. Go right ahead, nice and loud.
So, did you guys run into any animals while you were down in Antarctica?
Yeah, lots of animals. I mean, one of the nice things about being on the ship is that we're working 8 or 10 hours a day, and I was working quite a lot with the captain and the navigating officer on the bridge of the ship. That's the control room of the ship. So I sometimes had a really good view out into the sea and the ice that we were going through. And there, one of the things that I like the best, and people used to tease me because it always makes me smile, is we saw lots of penguins. And in particular, in this part of Antarctica, in the Weddell Sea, the penguins that are most adapted to the very cold conditions live there. And those are called emperor penguins, which are the biggest penguins of all, and Adelie penguin. And the Adelie penguins look, I always think, like people dressed up in tuxedos. But of course, they're only about 1 foot 6 inches high, but they're wonderful things. And when the ship comes close, sometimes they're inquisitive and they want to look at the ship. And other times they will jump into the water. Of course, penguins are really great swimmers. They're excellent in the water. So we saw lots and lots of those 2 types of penguin species, and we saw quite a lot of seals as well. But there are different kinds of seals. I talked at the very start about Weddell seals, which are very common in the Weddell Sea. But we also see seals called crab-eater seals. It's a funny name because they don't really eat crabs for the most part. They eat krill, which are like little shrimp-like creatures for the most part. So there were crab-eater seals, and then we also saw a few much bigger leopard seals. And the leopard seals actually prey on the crab-eaters, the smaller crab-eater seals, and on the Adelie penguins in particular. So what that shows is part of the Antarctic food chain, with the leopard seal at the top, which in turn eats some of the smaller penguins and the smaller seals, and those penguins and seals in turn eat the krill or shrimp-like creatures which are in the water. So those were the penguins and the seals are really the main kinds of big creatures that we see there, but we always like the penguins in particular. And then Evelyn says whales too. Tell us about whales, Evelyn.
Oh, it's absolutely amazing to see whales swimming by the ship. The way you first can usually spot a whale is by its spout. So you see a big spray of water going into the air, and you can see that from afar. And whales can be curious, so they often come by the ship. Mainly, we saw what's called a minke whale, which is a smaller whale with a slightly pointed dorsal fin or fin on top. And then there were also some huge humpback whales. And they're really interesting because they're not only huge, but they have things like barnacles on their surface, and their tail is white underneath. So when they dive, you can get a really good picture of the large tail. It's beautiful.
Yep. So the whales are great, and we both love the whales. One of the things I like to do is to take photographs of them, because both Evelyn and I have used the photographs in our little books on Antarctica and on Scott and Shackleton, for example.
Wonderful. That's so many different types of wildlife. And you mentioned the food chain, and the Royal Geographic Society, who's also partnering for the education, has a little bit about food chains on their website. So students and teachers, I recommend that you head over to their website as well and look for the article on the food chains. And we can also put that in the chat for you and send it out as a link as well. We are going to head over to Miss Long's class for their question next, and then after that, we can go over to Lucy. You have something in the chat that you can ask as well. So, Miss Long's class, you are next. You are unmuted. Go ahead.
How has your technology changed since you started your career?
That's a very good question. It's changed a huge amount. Because when I was an undergraduate student, when I was about 20 and first went to university, we didn't really even have computers then. So I go back quite a long way in that sort of way. So the technology has changed enormously. When I started working on glaciers and ice sheets, you always had to go there to make any measurements. And we used to stick, like as Evelyn is doing in Antarctica, we used to put lots of poles in the ground, and we used to survey them using technical equipment called theodolites. And those theodolites are all lots of brass work, a bit like binoculars, and lots of adjustments and so on. You measure angles and so on. And now instead of that, we use global positioning systems, or GPS, which you will know all about. And those are satellite-based systems. So we use an awful lot of material from satellite sensors, some of it imaging and some of it just measuring distances and so on. So the satellites have made an enormously big difference to us. The other thing that's really important is years ago when Evelyn or I used to go to the polar regions, we didn't always go at the same time, but when we were there and the rest of the family was at home, it was really difficult to talk because we didn't have mobile phones, we didn't have satellite communication. So quite often, one or the other of us might be away for 6 weeks and we had absolutely no communication with home at all. But now you've been talking, some of the classes are in this scheme have been talking directly to the ship in Antarctica, although the communications are sometimes difficult. And we were able to talk home to our children every now and again, although our children are a bit older than you. Our children are 30 and 26 now. So things have changed a huge amount in terms of the technology, both in terms of communications, and that actually brings us to Shackleton as well, because part of the reason we were in the Weddell Sea is to search for Shackleton's ship, the Endurance. And of course, once Shackleton had left port and came south just over 100 years ago, he had no communication at all with the outside world until he and the other expedition members came back in the end. Evelyn, any more on technology, or is that sum it up?
Well, I think one of the interesting things about when Shackleton was in Antarctica, as you all know, his ship got stuck in the sea ice, and they tried to dig it out. They used saws, shovels, anything they could. Well, our ship also was stuck for only a few hours in the sea ice, but we can use a big crane, and this big crane would carry a fuel tank and just rock it from side to side, carry it over from one side of the ship to the other, whereas Shackleton's men had to run to one side of the ship and put all their weight on that side, and then run to the other side and try to rock the ship back and forth. So that's one way where we really benefited. This rocking that we do with a big crane actually loosened the ship, and then we were free of the ice.
Wonderful. There's been lots of different technological changes. So we're going to head over to to Lucy. And then after Lucy asks her question, I see a few more hands coming up from Mr. Lee's class. And maybe we'll check in with some other classes to see if they have questions too. So we'll go to Lucy, and Miss Suzuki's class also asked a question in the chat. So we'll go Lucy, Mr. Lee, and then Miss Suzuki. Lucy, you are unmuted. Go right ahead.
What was the weirdest thing you saw there?
What was the weirdest thing we saw?
Well, there's lots of really fabulous, amazing things that we saw, firstly. But one of the funnest and surprising things that we saw was just recently. Now, in the ship, there's an opening in the bottom of the ship, and it's called a moon pool. And this opening lets the seawater come in, and it, most importantly, lets us put instruments down through the bottom of the ship into the sea. And just recently, there were 3 seals that came up into our moon pool. So we could see the seals swimming around and some little pieces of sea ice. And we didn't even have to leave the ship. And that was really fun. They were swimming in circles in our moon pool. So that was one of the strangest things.
Oh, that's a good one, Evelyn. Yeah, I hadn't thought of that. Another thing we saw, which is usually associated with deserts rather than the sea and rather than the polar regions, is mirages. That's where the temperature gradient very close to the sea surface or the desert surface or the ice surface is very, very strong. And it actually means that the rays of light near the surface of the Earth are distorted. And it means that you can see things that really we know are beyond the horizon, but they're raised up through this distortion so that you can see them. And they also shimmer as in relatively calm conditions, just a breath of wind disturbs that temperature gradient very close to the ice surface. They appear to wave and change their shape. And that was a really weird thing to see as well from the ship.
Excellent. And I think Holly has sent a picture to us of a seal in the moon pool. So we'll make sure that we can put that up on Reach the World site for all of you to see, students, as well. Great question, Lucy. So next we're going to head over to Miss Suzuki's class for a question, and then Mr. Lee's class. So Miss Suzuki's class, you are unmuted. Go ahead.
Why do scientists get sick? What happens?
Why do scientists get sick? Well, one of the reasons that scientists get sick when they're on ships is they can get what is called seasick. And seasick is being motion sick in the same way that if some people go on a roller coaster at the fair, they get sick because the motion, the up and down motion, is unusual for them. But when you're on a ship at sea, the waves can move the ship in various ways that actually disturbs some people's sense of balance, and that is called seasickness. Now, I'm really lucky. I've worked on ships and icebreakers in the polar regions for more than 30 years, and I'm one of the lucky people who doesn't get seasick. But I can assure you that when we first go out from harbour into rough seas, probably 80 or 90% of people on the ship, the scientists and the crew sometimes as well, get seasick. For most people, it only lasts for about a day until they get used to the motion of the waves. But it's quite unpleasant, or so I'm told. Evelyn?
Mm-hmm. And you know, it's a little bit surprising, but when you've been on a ship for a long time, you get used to the rocking back and forth and you get used to the motion and you don't notice it. But then when you go back on shore, when you go on the land, you start to feel it. The land's not moving in the same way the ship was, and you could actually get land sickness. It's the same kind of thing, but it's on the land.
Yeah, so you feel as though when you first step off the ship for perhaps half a day or a day, you feel as though you're swaying around very slightly on the land. And that's weird. That's quite odd, because the land, of course, isn't moving, it's us.
The kind of sickness that people got 100 years ago in Shackleton's time is very different than the kind of sickness we get today. Although their ship was much, much smaller, about a third the size of our ship. So I think seasickness was a really big problem. The other kind of sickness they got was from not having all of the vitamins that we need, vitamin C in particular. So they get things like scurvy. But we don't have those problems today at all. So
no,
we're very lucky.
Today, of course, we take vitamin supplements when we're on the ships. And also, to be fair, the food on the ship that we were on was actually very good.
Very good.
We enjoyed our food on that. When you camp on the ice, of course, as both of us have done a number of times in the past, then you have to cook up your own food. And that food is often freeze-dried food, and it's much less interesting. So you have to rehydrate it with water. You have to boil it up yourself. And that sort of food is not so nice, really. But when we were on the ship, we had great food this time, didn't we, Evelyn?
Very luxurious.
We heard from Holly and two of her guests one day what their favorite food was on board the expedition. And I remember Holly telling us that she loved the steak that you guys had on Saturday nights.
That's right. Well, one of the interesting things about ships is that when you're working, whether you're doing science or just traveling on ships, one day is very much like the rest. And you have to really keep a note in the calendar to see when it's the weekend, because of course, you know, our time on the ship is precious to do science in a remote part of the world. And so we work every day on the ship. So there's no time off at the weekends. But what happens on the ship is usually to mark the fact that it's Saturday, and this is a tradition on ships in a lot of countries in the world, is they always have steak on Saturday evening. And so we look forward to Saturday evening and steak. The other thing I liked on the ship is that I had soup almost every day. I had soup almost every day at lunch, and I really liked the soup as well.
Excellent. So students, do we have any more questions for Julian and Evelyn about maybe some of the science that is happening on the Weddell Sea Expedition as well? So Mr. Lee's class, I know you guys are next. And then it looks like Miss Bemis's class has a question and Mr. Rowett's class. So we'll go in that order next. All right, Mr. Lee's class, you're unmuted. You can go right ahead.
If the orange submarine were to break underwater, what would happen? Like, how would you get it back?
Well, that is a problem, and it's a particular problem under the floating ice on the sea surface, because it's very difficult to get the submarine back if that happens. And we had an incident like that quite early in the expedition, where the orange submarine got stuck under a sea ice floe, and we actually had to spend 4 days rescuing it. And the way we did it mainly was that the ship, as it's an icebreaker, actually kept backing off and then ramming into the ice floe, and it actually split the ice floe into many small pieces, and eventually we got close to where the submarine was stuck underneath. And then we used the bigger square yellow vehicle that Evelyn was talking about earlier, which is connected by a cable to the ship, and that went in under the sea ice, and actually it has robotic arms, and one of these robotic arms actually grabbed a hook on the submarine and pulled the submarine out. So your question's a really, really good one, because we actually had to spend 4 days rescuing one of the submarines earlier in the cruise.
Yes, excellent. And next we have got Miss Bemis and then Mr. Rowett. So Miss Bemis's class, we're going on over to you, and you can unmute and go ahead.
We couldn't hear that, I'm afraid.
There you
Oh,
go.
there you go.
That's better.
Okay, I'll hold it down the whole time. Demi.
What activities did you guys do on the Weddell Sea Expedition?
We did lots of things. We did a lot of different science things. Sometimes we were able to stop the ship and go out onto the sea ice floes and do the sort of sampling that Evelyn was describing earlier. But before we started doing the science expedition, science part of the expedition, and before we actually left the place where the ship came and picked us up, there was a bit of waiting around, because we came in on 3 different flights from South Africa. And during that waiting around time, we all got out on the sea ice and we played football. No, it's America. So we played soccer. Yeah, we played soccer on the ice. And that was really quite a fun thing to do. But in terms of the science, we got out onto the sea ice and we made measurements. But we also deployed and sent down a lot of instruments from the side of the ship. So we have a lot of instruments that are on wires or cables, and those are winched out from the side of the ship, and they're let down right through the water to the sea floor, and then they're pulled up again. One of those measures the salt content and the temperature of the water right through the thickness of the water column. And it takes several hours, dependent on the precise depth of the water, for that instrument to be lowered down to make its continuous measurements and then to be pulled back up. It also samples water. And then when the instrument comes back onto the deck, we subsample the water and we analyze various aspects of the chemistry of the water. And we also look at the water under a microscope and see the little micro creatures that are in the water. And those creatures often tell us something about the water, because different creatures like different kinds of food, and they like different temperatures to live in. So the type of creature can tell us something about the temperature and also the saltiness of the water. But Evelyn was doing some other things to do with trying to understand the geology of the seafloor and the layer cake structure of the sediments. Do you want to say something about that, Evelyn?
Sure. Well, one of the things that I was interested in, and I was doing, was taking samples from the seafloor. And I didn't just want the surface of the seafloor, because that would give me a good story about what's happening right now. But I wanted to know what was happening hundreds and thousands of years ago. So what I did was I sent over long tubes. They're called coring equipment. It's a long tube. It could be about 20 feet long at the longest. And we'd send it down to the seafloor, and then we'd let it drop through the sediment and the seafloor, and it would bring up, say, 20 feet of sediment. And that will tell me, when I analyze it in detail, about the kind of rocks and whether or not the ice was over that area at certain times in the past. So I'm hoping to get a story about the glacial history, when the ice shelf was over the area, when the glaciers were over the area, and when there were none, from these very long, very old sediment cores. And that was something I'm very interested in. Some of the biologists were also interested in cores, and they sent over the back of the ship, not just one long tube to collect 20 feet of sediment, but several small tubes so they can get a picture of what's happening more recently. They wanted to know what was happening the last couple hundred years, and also what kind of animals are in the surface of those sediment cores. So we did a lot of coring work off the back side of the ship. And as Julian said, these do take a long time because they have to be lowered right down to the bottom of the ocean, to the seafloor. And that could be up to 3,000 meters. That would take a very long time.
Yeah, that takes about 6 hours, doesn't it? And all the time, the ship is also receiving satellite pictures of where we are within the sea ice. Because one of the things about the ship, although it's a very big ice-breaking research vessel, it still needs to know where the ice is particularly thick and where the ice is thinner and where there's open water, so that it can pick the quickest path to the sites that we want to investigate in more detail. So we also need to know about the satellite imagery as well, and what that tells us about where we can go and how easy it is to get there in the ice-infested waters around Antarctica.
There is a lot that goes into doing research on a boat in Antarctica with the ice. To follow up on that student's question, how much of the data did you as the scientist analyze when you were on the vessel, and how much of it have you had to bring back with you to your labs in your respective universities to analyze now that you're back off the vessel?
Yeah, it's a really good question, and something the newspapers quite often ask us, because they want instant results. And of course, some of the things that we do don't have instant results because there's a lot of analysis to be done when we get back. The images, the pictures that we have of the sea floor we're working on at the moment, those are accessible to us now. The photographs that have been taken from the orange submarines, for example, we're working on those now. But some of the things like Evelyn's sediment cores, the results will not be out in full for at least a year. Evelyn?
We can get an idea of what kind of sediment we're looking at from looking at the tops and the bottoms of the cores, and when we cut them, that tells us whether we're looking at a glacier sediment, so when the ice was grounded or on the bottom of the seafloor in that area, or whether it was floating. We can get ideas, and then it tells us where we might want to take new cores. But the detailed analysis we'll be doing when we get back to the lab. So when the ship comes back and we get the cores over from South Africa, we'll have a lot of work, and it'll be very exciting work.
Wonderful. We'll have to all stay tuned for the next year or so to hear more results. So let's head over to Mr. Rowett's class for your question. We'll go ahead and unmute you and go right ahead.
All right. Carlos, start with the question.
What do you guys do to not get frostbite and hypothermia?
Can you guys hear us?
Yep,
Yes,
absolutely.
That's a very good question because it is very, very cold. We take a lot of precautions. The most important one is equipment. Now, we're very lucky in that we have very warm equipment, but we still have to put layers on. We'll have maybe on the coldest day, I think I had 2 layers of long underwear on, then an outer layer, wind protection, and then I probably had a layer of long underwear top, 2 jackets, and then another outer jacket. Now that takes care of my body core, but hands and your head are really important because you lose a lot of heat from your head. So it's very important to wear a hat, maybe 2 hats, and something to protect from the wind, and then gloves, because if you don't wear gloves, even if you take them off for a few minutes, your hands feel really cold really fast, and you can get what's called frost nipped. And that's not frostbite, but it's just when it starts to hurt and starts to turn white. And when that happens, if that happens, you have to immediately get yourself warm again, because you don't want that to progress. So your equipment, your what you wear, and on your feet as well, is very, very important.
And one of the things that's also important, as Evelyn suggests, is if you get frost nip, which is the sort of precursor to frostbite, if you get frost nip, your skin will turn white, and most often it can happen on your ears or your nose or the tips of your fingers. So it's really important that your friends keep a lookout for you as well, especially if you're working outside the ship on the ice, because they can see when that starts to happen, and that can prevent frostbite if it's identified. So keeping an eye on these things, as well as dressing up warmly, is really, really important.
Wonderful. There's such a big piece of community involved in all of these expeditions. So Mr. Lee, it looks like your class maybe had another question. Is that correct? So we'll head to you all, and then we'll go back to Mr. Rowitz. I saw a few hands up in your classroom as well. All right, Mr. Lee's class. Are you, hold on, we're still not muted. Okay, go ahead.
We don't have any questions at this time. They've been answered.
Okay, excellent. So we'll head over to Mr. Rowitz's class again.
Hands up, hands up.
Go ahead.
Erica, come over to the laptop. Yeah.
How would you tell if something was a piece of the Endurance or it was a different object that had been floating by?
So a question about the hunt for the Endurance. If you find a piece of a ship, do you know if it's from the Endurance or not?
Oh, right. Okay. So the question is about the Endurance and how we would actually know it was the Endurance. Well, at the Scott Polar Research Institute in Cambridge, where both of us work, we have all the plans of the Endurance. So we know what to expect in terms of the different pieces. But the thing is, because the Endurance sank in such a difficult part of the world to get to, it's the only wreck that's going to be down there. So there's no possibility of mistaken identity. Very few ships have ever been to this part of the Weddell Sea, partly because it has such a huge cover of thick sea ice. And of course, that's why Shackleton's ship was first trapped in the sea ice, drifted with the ice for 10 months, and was then crushed. And in fact, since the time of Shackleton's ship, which was 104 years ago, there have probably only been about 3 ships that have ever got to this place. One of them was a German research vessel called Polar Stern or Polar Star. Another was a Russian icebreaker called Captain Kolebnikov. And the third one is our ship, the Agulhas 2. So there's almost no possibility of mistaken identity, because Shackleton's is almost, well, it's certainly the only wooden ship that ever got there.
Wonderful. And it looks like you all have a follow-up question in Mr. Rowitz's class, or that was excitement from the first question. Let's see if you have a follow-up.
Hands up, raise your hand. Please. All right, Michael, you have a question. Come on over.
Would you use machines to go down there, or would you like dive down there by yourself?
Can you say that again, Michael? We didn't quite hear you.
Okay. Do you use machines to go down there, or do you go down there by yourself?
Do we use machines to go under the water?
Yes.
No, we don't go under the water. Diving in the polar seas is really, really dangerous, because there's, as well as the normal problems of pressure underwater with diving, the additional difficulty is the water is very, very cold. Sometimes, in fact, in the polar regions, the water can be colder than 32 degrees Fahrenheit. Normally, of course, water would freeze at 32 degrees Fahrenheit, but because the seawater is very salty, it freezes a couple of degrees colder than that. So the water sometimes is 32, 31, 30 degrees Fahrenheit, but still it's not frozen. But that's not water that you want to go into, because you would freeze very, very quickly if you did that. So we're actually very careful not to get into the water. And we have to do quite extensive, what is called sea survival training before we go on the ship. So Evelyn and I, before Christmas, before we went down, both had to do a refresher course in sea survival training. And the key thing that they say there is, unless the ship is actually sinking, you never want to go in the water. And of course, even in those circumstances, they have suits which are called immersion suits, which actually are dry suits. And if you put those on and you get in the water, they will keep you completely separated from the water, and you just float on the water rather than in the water. So in terms of safety, we're very careful not to go in the water unless we absolutely have to.
Wonderful. And also with the depth of things that you're searching for and the science that you're collecting, it sounds like things are pretty deep down in the water as well. So it wouldn't be as safe for humans to go down that deep either.
That's a really good point. I mean, they're way below the depth to even the most serious divers would ever get to, because the wreck of the Endurance is actually in about 9,000 or 10,000 feet of water, and human beings, unless they're in submersibles, would never go there. And explicitly, the yellow square remotely operated vehicle and the orange torpedo-like things are not for people. They're all robots.
Yes. So students, we probably have time for just about one more question from each class. So if you have one more question, if you want to put your hands up, and we will come to you for one more question for each class. All right. Was that a hand in Miss Chapman's class as well? So we'll start with Mr. Rowett's class, and then we can head to Miss Chapman's if they have a question as well. So Mr. Rowett, go ahead.
All right, thank you.
What were some risks What were some risks you had to take to continue your journey?
Some risks that we had to take on our journey.
Well, one of the first difficulties in the journey is that you actually have to get to Antarctica. Now, it's a long way away, but a plane might leave from, our plane left from South Africa to go to what's called Wolfsfang. It's a runway in Antarctica, but the weather has to be clear there. And if the weather isn't clear, you can't land there. So you have to have enough fuel to actually fly up half the way and then decide if it's clear or not. If it's not, then you have to turn around and have enough fuel to fly all the way back to South Africa. So getting there is one of the difficulties. And in fact, it took us 3 days to get there, because flights were canceled, it was foggy, you couldn't land. So the first difficulty is just getting to Antarctica.
And another one of the risks is that the ship, although it's an icebreaker, can still have problems moving the ice. And icebergs, which are formed from ice sheets, so are much thicker than the sea ice. And so the ship doesn't want to crash into bigger icebergs. And so what happens when it's foggy and the visibility and the area that the captain can see ahead of the ship is limited, is the ship has to slow down to make sure it doesn't hit the large icebergs, or certainly just pushes them out of the way rather than hits them when it's going fast. So there are a number of things like that, often to do with the weather, like Evelyn says, for flying in and out, that we actually have to be very careful of. So the worse the weather, the more careful we have to be. And the other point, which somebody made earlier, of course, is the one about the cold. And we have to mitigate that, as Evelyn says, with the best possible clothing and care of that sort.
Wonderful. And next we have from our chat, Ms. Hagertop's class has a question, so I'm going to unmute you all so you can ask it live as well. Go right ahead.
What is the biggest difference in research from the Arctic to the Antarctic? And if you had to go back to either one of them, which one would you go to and why?
That's a really, really good and difficult question. Now, I've worked a lot, and so has Evelyn, in both the Arctic and the Antarctic, and we really like both of them, and there are interesting things going on in both. One of the problems of doing field work in the Arctic, which is not present in the Antarctic, is that in the Arctic you have polar bears, and so when you camp or do field work out on the ice in the Arctic, the polar bears can actually kill you. They don't particularly. They are quite dangerous creatures, and so in the Arctic we have to keep a close eye open for polar bears, and we normally have a polar bear watcher. And we come off the ice if polar bears are around. And that's something we don't have to worry about in the Antarctic. But in terms of the science, the Arctic and the Antarctic, although they're both very cold, are quite different. The Antarctic is a big continent, the continent of Antarctica, covered with lots and lots of ice, which is surrounded by a great big ocean, the Southern Ocean. The Arctic, geographically, is the opposite of that. It's a great big ocean surrounded by the land masses of North America, Europe, and Asia. So the center of the Arctic is an ocean, whereas the center of Antarctica is actually a landmass. And therefore, if we want to understand what's going on at the South Pole, we have to understand how the glaciers and ice sheets are working. If we want to understand what's going on at the North Pole, we have to understand more about polar oceanography and sea ice. But of course, all those things are interrelated. And so a lot of the topics that we study in the Arctic and the techniques that we use are similar to the ones that we use in that other cold region, the Antarctic.
Well, I'd agree with Julian. Although some of the questions that we're answering about what's happening to the glaciers and ice sheets in the world, global climate change, are the same in both poles, the Arctic and the Antarctic, I probably prefer the Antarctic simply because I don't have to look over my shoulder all the time for polar bears.
That's a good
I
point.
can relax and just think about the science without worrying about being attacked.
That's a really good point. And we both like penguins.
And we both like penguins.
Yeah, that seems like such a small thing you wouldn't necessarily think about, but has a lot of impact on how you can conduct your research, is what are the elements that are around you. So Miss Chapman's class, did you all, I wasn't sure if we saw a hand, but I think so because you're standing up. So we'll head over to you for a question. You're unmuted.
Uh-oh. I can't hear you now. Okay, go ahead.
What is your favorite part of the expedition?
What is your favorite part of the expedition?
Oh, gosh.
Wow. Well, I think, I mean, let's say we all enjoy the science, and that's great. But in terms of the experience of it, I thought that landing in the little jet on the ice runway at Wolf's Fang, where the great big rocks that I showed at the beginning were sticking out, that was pretty impressive. And the other thing that I think is fantastic about going on the ship in the Antarctic is the light changes all the time. You see huge icebergs, you see the sea ice, and you can go out one day and it's very dark and the clouds are low, and you go out another day and it's bathed in beautiful sunshine. So the way the weather changes and the way that the ice and even the ship itself look different as the weather changes, I think is really, really good fun.
Now, and I thought those were absolutely brilliant things as well. And it was an amazing place to work. But one of the things I thought was really super special was when the icebreaker, when our ship, the Agulhas, was crashing through some of the sea ice to find the orange torpedo underneath, we could see huge pieces of the sea ice turn over and establish equilibrium. So they turn over. And I just thought it was fabulous to be able to see the underside of the ice floe. The features, the way it was, some of them were rough, some were smooth. You could see that there was animals, some biology, very small animals in there. And it was very special to see the underside of the sea ice.
And we even disturbed a couple of seals at one time, didn't we? I think they were quite surprised to see the ship there, and they came up to the surface and effectively looked at us, yes, and then swam away.
Wonderful. It seems such good memories of the expedition. So I'm going to see if Corinne, do you have one final question for us? No, you're good? Okay. Excellent. So students, thank you so much for joining us today. And Julian and Evelyn, a special thank you to both of you. I know you're busy starting to get analyzing all of the data that you collected and readjusting to life back on land. So thank you very much to both of you for joining us today and talking about the Weddell Sea Expedition, as well as some of the exciting science that you guys conducted while down there.
And thanks to everybody in all the schools for all the great questions. Really appreciated them. Thank you so much.
It's fabulous to see everybody so interested. That's really wonderful.
Yes, we have so much interest. We have over 200 schools following you guys just in North America alone. So it's wonderful. And some of our classes had to leave a little bit early to get to lunch or other classes like math class. But I'll go ahead and unmute everyone so everyone can say a nice thank you to Julian and Evelyn for today as well.
Thank you.
All right, so thank you so much. And for everyone, we do have another phone call with the ship on Friday at noon, and it is a YouTube live one. So we have sent your teachers the link and sent it out. So please feel free to share that link with anyone that you think is interested to hear from the vessel. We will be having Dr. Lucy Weddell to talk about the marine biology, and then the Chief of Exploration, Menson Bound, talking about the search for the Endurance. So please remember to tune back in on Friday. And thank you again to you, Julian and Evelyn, for today.
Great pleasure. Bye-bye.
Thank you. Bye.
All right. Bye.